So welcome to lesson 5.1 and unit 5. We're going to be finding functions in alternative forms to slope-intercept form. So we're going to be finding points on a line in this lesson with the intercepts, both x and y. Start with this. So the y-intercept is this point right there, and it is 0, -6. That is the y-intercept. Make sure that you have a 0 in front of -6. If you forget that 0, it's wrong. Intercept is a point. The x-intercept is 2, 0. That is the x-intercept. Find 3 other points on the line. Okay. Well, you're looking for good intersections. Right there where I circled, there's a fraction or a decimal in that one, so it's hard to tell. So we want to find easy ones. We want to find ones that have good intersections. There's one, and that is 1, -3. Here's another one up here. What's that one? 5, 9. And we could do this one down here. And that one is what? -1, -9. How many total points on the line? Hopefully you're not counting, right? There is an infinite amount of points on a line. You just found some of them. But it turns out that of the infinite points on a line, the intercepts are really the two most important for us in class. All right, so we have been working on slope-intercept form, right? We know this is y in the form y equals mx plus b. This is the form we're going to be using it often from now on, and this is called standard form. All right, and it is very different than slope-intercept. So what you're going to do on this screen after you take the notes is realize that one of these is in slope-intercept and one is in standard. So it says copy the linear equation which is in standard form. Well, hopefully you realize this. It's this. So let's look at that. That's in ax plus by equals c, where a is 3. B, what is b? It's 1, right? Because 1y is y. And c there is 7. And that's called standard form. This is still a linear function. We can still graph it. It still makes a straight line. All right, same thing here. Find the one in standard form. So you have to be able to look. There's another third form coming. You have to be able to look at a function. Both of these are function because they still have inputs and outputs. X is still the input, y is still the output. And you have to realize that is in standard form. A there is 3, B is -2 there. That's what's going on there, and C is 8. All right, that is standard form. What's the name of the old one? Slope-intercept form better come to mind. All right. All right, so we're still doing the same game that we have been doing all along. X is our input here. We're going to put X is 3 in there. And we're going to get our output, but because it's in standard form, it's not quite as straightforward, right? So you have to figure out what y must be there. So, well, 2 times 3 is 6. 6 plus y is 8. So that's an equation. We're going to subtract 6 from both sides, whether in your head or not. And you're going to say the point on the line is, so the answer is not y equals 2. It says find the point on the line where x is 3. The point on the line where x is 3 is 3, 2. In this linear function, when x is 3, y is 2. Try that one. So we're going to put 3 there where, we're going to put 3 there where x is. -3 times 3 is -9 plus 2y equals 12. We're going to solve that two-step equation by adding 9 to both sides. And we're going to get 2y equals, is that 21? And then we're going to divide both sides by, and y is what? 10.5. All right. Now, when we make points, right, I often tell you that you can leave improper fraction 21/2. But when we make points, right, the point on the line here is 3, 10.5. Because plotting 21/2 is not obvious, right? But hopefully plotting 3, 10.5, right, is halfway between 10 and 11 is more obvious. Try this one. All right, so this time I'm giving you the output, and you're going to find the input. You can do that as well. So we're going to put, 4 in there. It's the same function, by the way. Oh, no, the same function as the one above it. Yes, we had a different function there. We're going to solve that. It's a two-step equation. So x equals 2. So what point, right? So this is the point 2, 4. Please be careful. If I give you y, right, then you have to find x. So then the answer is 2, 4. So 2, 4 is one of the infinite amount of points on that line. 3, 2 is also on that same line because these were the same function. We had a different function there. Okay. Okay. So please, all y-intercepts start with 0. Does that mean if a point starts with 0, it has to be the y-intercept of the line? Yes, it does. Right? If it ends in 0, does it have to be the x-intercept of a line? Yes, it does. All right, so find the x and y-intercepts here. So the y-intercept is 0, 8. It has to start. If you tell me a y-intercept that doesn't start with 0, it's wrong. This is the x-intercept there, negative 4, 0. You tell me an x-intercept that doesn't end at 0, it's wrong. All right, so those are the x and y-intercepts. Let's do that again. And do not abbreviate this y, all right? It's a y-intercept. That's y right there. Y means y-coordinate, right? That's x, x-coordinate. The y-intercept has an x-coordinate, an x of 0, and a y of 6. If you say y equals 6, that's wrong because that's the y-coordinate. It's actually also something else. All right, and so that's the y-intercept, and this is 6, 0, and that is the x-intercept. Okay, so there's that same function we've been doing, 2x plus y equals 8. So what does it say? It says we can find the x and y intercepts of any linear function by setting x and y one at a time equal to 0. So you're going to do this twice. So there's no shortcut, all right, that I'm not telling you, all right? You're going to find both of them, all right? So to find the y-intercept, we know the x value has to be 0. Solve that equation, right? The x-coordinate of every y-intercept equals 0. Well, 2 times 0 is 0. You're not going to write every step like this. And so we get y equals 8. Y equals 8, not the answer. What is the y-intercept? 0, 8. That's the answer for the y-intercept. But every y-intercept has an x-coordinate of 0. Now you're going to do the same thing for the x-intercept. What do we know about every x-intercept? The x-intercept has a y-coordinate of equal to 0. I guess I should write it out. I'm going to write it out the long way, but you don't have to do that. All right, so there's the y-coordinate equaling 0. Well, we're going to solve that equation. 2x equals, right, this is 2x equals 8. Divide both sides by 2. X equals 4. Again, that's not the answer. What's the x-intercept? The x-intercept is 4, 0. That's what your homework has to look like today. All right, so do it for this function. I'm always going to start with the y-intercept, just to be consistent, and then do the x-intercept. So for the y-intercept, I make the x-coordinate equal to 0. For the x-intercept, I make the y-coordinate 0, and I solve both of those equations. So negative 3 times 0 is 0. 0 plus, so this will just cross out, and you can just do that. 2y equals 12, so I did it the long way the first time, but you can just cross that out, divide both sides by 2, y equals 6, and so the y-intercept is 0, 6. Now in the x-intercept, that one crosses out. Divide both sides, right, by negative 3, x equals negative 4, the x-intercept is negative 4, 0. So that's a shorter way of showing your work, okay? So this is a linear function. I now know that it has a y-intercept of 0, 6, it has an x-intercept of negative 4, 0, and it must look like that. There is no other line that has this x-intercept and this y-intercept. There is only one line that has that, and there it is. Okay, so let's just do that again with one that has fractions in it, just to see that. Got to spell intercept correctly. So for the y-intercept, you make the x equal to 0. For the x-intercept, you make the y-coordinate equal to 0. So this is negative 7y. Let's write it out just so you see it. Negative 7y equals 2. Divide both sides by negative 7. Y equals negative 2 sevenths. Yeah, that's possible. The y-intercept could be 0, negative 2 sevenths. We don't do that a lot because it's hard to graph, but there's an infinite amount of different y-intercepts, and most of them have fractions or decimals in it. All right, so this is 3x equals 2. Divide both sides by 3. X equals 2/3. That means the x-intercept is 2/3, 0. What does that mean? So 2/3, 0. Here's 1, right? Here's 2. 2/3, 0 would be right about there. 2/3 the way along there to 1. 0, negative 2 sevenths. Well, here's 1 again, negative 1, right? So that would be 2 sevenths the way down there. And then the function must look something like that. I've zoomed in because if I was doing it the normal size, you wouldn't really be able to tell. All right, so now we use this technique in standard form. Then when I change it back to other forms, and there's many other forms, people get confused, but it's the same rule. All right, so to find the y-intercept, right? This is not in standard form, but this technique still works. The y-intercept, you make x equal to 0, right? So you're going to make x equal to 0. Well, 3 times 0 is 0. That crosses out. Y equals negative 9. The y-intercept is 0, negative 9. That technique still worked, but we already knew that's what form is that? Oh, that's slope-intercept. I didn't need to do that, but please understand what we're doing today would work. You just didn't, why we hadn't learned this before, because you didn't need it for slope-intercept form. You already can see the y-intercept, but it will work to find the x-intercept. We didn't need it for the y-intercept, but we could find the x-intercept, which we never used to do, but we could have. So let's do that here. So we're going to make the y-coordinate, right? The y-coordinate equal to 0 for the x-intercept, and we're going to solve that equation. So do that. So you would add 9 to both sides. 9 equals 3x. Divide both sides by 3. 3 equals x. That means the x-intercept is 3, 0. So when we were doing slope-intercept, we could have found the x-intercept. We just didn't need it because we already had the slope, right? We didn't need the x-intercept also, all right? But remember, this is y equals 3x minus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. It has a slope of 3, right? Going over 1 up 3, over 1 up 3, over 1 up 3. Oh, and look at there. There's the x-intercept, 3, 0. That's the line. Excuse me. Oh, I tried to pause it for that sneeze, but it didn't. All right, here we go. All right, so we're at the practice. So do these. Now careful on that. This is not an intercept. That's the 0.61. Remember how this lesson started. You can do this for any points. It turns out you do the intercepts the most often because the math is easier, right? The math was easier when we were putting 0 in there than 6. But you could do this for any point, any value of x, any value of y, and find the point on the line. So here we're going to put 2 where y is, right? That's y equals 2. So you put 2 equals 1/2 x minus 3. We're solving that. We're adding 3 to both sides. 5 equals 1/2 x. We're going to multiply both sides by the reciprocal. And 10 equals x. What is that? That means there's this point. X is 10, y is 2, is on that line. So this is in what form? Slope-intercept, right? You know that because y is by itself. What was the other one in? The other one was in standard form. You need to memorize that because there's a third one coming. You have to look at that and say, oh, that's in ax plus by equals c. That's standard form. That one is in y equals mx plus b. That's in slope-intercept, just by looking at it. All right, so now you're asked to find the intercepts. So then you're doing, truthfully, easier math, and that's why you do this the most often. So for the y-intercept, you just make x equal to 0, and that very nicely crosses out. You divide both sides by 3, y equals 5. The y-intercept is 0, 5. If you skip that step and you just put y equals 5, massive points off, because it means you don't understand what you're doing. X-intercept. For the x-intercept, you make the y-coordinate. That's a y-coordinate equal to 0. That crosses out. Divide both sides by 2. So you can leave 15 halves normally, but that's 7.5, right? Because 14 halves is 7. So this is the x-intercept is 7.5, halfway between 7 and 8, 0. Here, same, even though it's in slope-intercept. Now, on the homework, if you see this, you're allowed to just write 0, -3 and not do the work. Yes, because, right, that means you recognize that that's in slope-intercept. But if you do the work, it will come out as 0, -3. It will, right? And x-intercept, we make y equal to 0. So we add 3 to both sides. 3 equals 1/2 x. Multiply by the reciprocal. 6 equals x. 6, 0 is the x-intercept of that line. Memorize those names. Thanks very much.